Today we are going to discuss uncountable set with Lebesgue measure 0. So we start by base 3 expansion of base 3 expansion of numbers lying between 0 to 1 interval. Let me make this square bracket. Okay, so you know that the digits would be 0, 1 and 2 after a decimal. Only these digits could be used to represent such numbers. This 0 to 1 belongs to real line. Now, so in base 3 expansion, it would be the first digit, let us call it A1, the second digit, let us call it A2, third A3, and so on and so forth up to infinity. So the number 0 in base 10 or the number system we use corresponds to 0.000 so on in base 3, right? And the number 1 would correspond to 0.222 up to infinity. Okay, if you are not getting this, so this is just basically the first digit is 2 by 3 when we expand it, the second digit is 2 by 3 square, and this is an infinite GP, so its sum is first term by common ratio, which is equals to 1. So everything is perfect till now. Now what we'll do is, as we know that these have some expansion of the form A1, A2, A3, A4 and so on. So what I'll do is delete all those sequences for which A1 is equal to 1, that is 0.1 something something something. I'm going to delete it. So what we would be left with is 0.0. These sequence would be remaining, and 0.2 such sequence would be remaining. Okay, so when we delete this A1 equals to 1 from the whole set, so we are left with a measure of, so let's first of all see what this A1 equals to 1 occupy, like what is the interval that it occupies. So the lowest number we can make with this is 0.10000, which is nothing but 0.1 in base 3 representation, which is 0 plus 1 by 3. So the smallest number that we can make with A1 equals to 1 is 1 by 3 in real numbers or in base 10. And similarly, the largest number that we can make is 0.1, and rest all the digits are 2, which is nothing but 1 by 3 this first term, then 2 by 3 square plus 2 by 3 cube and so on. So this is nothing but a GP once again, whose total sum is first term by 1 minus common ratio. This is 2 by 3, so effectively this whole term is 1 by 3, So we get 1 by 3 plus 1 by 3, which is 2 by 3. So when we delete, so when a1 equals to 1 is deleted, that means as a1 occupies interval 1 by 3 to 2 by 3, right, we are left with 0 to 1 by 3 and 2 by 3 to 1. Okay, so after deleting this sequence, the starting measure of 0 to 1 was 1, but now we are left with these two lengths. So each of this interval corresponds to 1 by 3 measure. So the total measure that we have remaining here is 1 by 3 plus 1 by 3, which is equals to 2 by 3, which we can write it as 1 minus 1 by 3. This is the measure lost due to a1. When we lost a1 equals to 1, we are left with the measure 2 by 3. Okay, so continuing the discussion forward, now let's delete the sequence which has a2 equals to 1. That means we would now be remaining with the sequence this. Now a2 cannot be 1, so 0.00 something something something. This would be the lowest number if all are 0, and the 0.02, and the highest that we could get is 0.2 something something something. If all these digits are 2, then this would correspond to the highest number. Okay, that we are left with. So effectively we are deleting this sequence 0.01. So this thing corresponds to 1 by 3 square, as it is in the second place, and the upper limit would be 1 by 3 square plus when all these digits are 2. Why did it go blur? When all the rest of the digits are 2. So we are deleting all such sequence. So this number corresponds to 1 by 3 square plus infinite GP, where the first term of this is 2 by 3 cube here, 1 minus 1 by 3, which would again give 1 by 3 square. So overall this would give 2 by 9, right? Also such sequence remain 0.0, not 0, 0.20 something something and 0.22 something something. So now for this we will have the interval. So this is just like, this means we have deleted such type of sequence. So this interval would correspond to 2 by 3 from here plus 1 by 9 to 2 by 3 plus 1 by 9 plus the rest of the GP. So its first term would be 2, and since it is a third digit, it would be 3 cube, 1 minus 1 by 3. This would again give you 1 by 9. So this is 2 by 3 plus 1 by 9, comma 2 by 3 plus 2 by 9, right? So from this thing, this occupies interval of 1 by 9 to 2 by 9, and this thing occupies interval from 3 2s are 6 plus 1 7 by 9 to 8 by 9. So when we are deleting such sequence, zero point not 0 0.21, then this corresponds to a measure of 1 by 9, and this corresponds to a measure of 1 by 9, right? Because each of this interval has a length of 1 by 9, right? Both this interval is 1 by 9 and even this interval is 1 by 9. So the measure that we are left with after this process is, earlier measure was 2 by 3 after deleting a1. Now we have to remove 2 by 9. This gives us 4 by 9, which is nothing but 2 by 3 square. So we can see there is a pattern. First the measure was 1, the next measure was 2 by 3 after deletion of a1 equals to 1. After deletion of a2 equals to 1, we got the remaining measure as this. So we can see that in general, after we delete an equals to 1, we will get a measure corresponding to 2 by 3 to the power n. But as n tends to infinity, the measure would tend to 0. The measure would tend to 0. But we know that the set is still countable, as we have left so many uncountable, so many numbers in the set. The set would be uncountable. Like, there would be some elements left which we are not able to count, okay, but still their measure tends to 0 as n tends to infinity. So by this procedure we can get a set which is uncountable with Lebesgue measure 0. Thank you.